Hello, this is Rasmus, and I will start on my hand in code 4 for the image processing course at medialogy. Okay, I will just take them in this order, all 50, so we go from edge detection to impose to some I invented by combining two filters: Gaussian blow, maximum, mean with a disk, median, minimum filters, and what's called morph operations, and pre-width and sobel at the end. And that is also edge detecting, just I've done some more out of it. So first, edge detection, vertical lines. So here we have our kernel. I have just used a pre-width kernel for this operation, and then we go to the test app, and here we have our nested for loop. We create a sum and for loop for each column. We take through the kernel's y and x coordinates. We take 1 because we have to start 1 back, 1 up, it's y value, and the x because we have to start 1 back. So that way we go through all the pixels and we add them together, so we get minus and plus. So that way we will find an edge. We set a threshold for how big this difference have to be. Right now I've just taken to 150, and then we set each color to white if they are above this threshold, and black if they are below, and this will be the result. As you can see already here, it will get vertical edges but not the horizontal. And yeah, you can also see it here, because my shoulder is slightly rising, it would always also find some vertical edges there. And that's the same deal about the window. Right, onwards to next. And that will be the emboss. That's a special kernel which also take this, and then we set the pixel value to something different. Also, you can see the kernel here I've done it by a 5x5, and we have minus in a crooked way, crooked line instead of just vertical. And as you can see here, same deal with the color and the way we go through the kernel. And I made a bit lower threshold, and I set the white color to something different, and the black color as to be the lines. And the result will look like this. It actually look most fun if we take something that is flat and hold up against it, because it will make it kind of pop out. As you can see here, oh, this is not that good, it reflects. Take a piece of paper, maybe not good with some confidential, or maybe this one. As you can see, this is more of a flat surface, but it will look like it pops out. And this got me thinking that maybe I could make a kind of cartoon filter by combining it with the alpha blend. So I hope it's okay. I made my own kind of filter here, the emboss filter with cartoon look. And we're gonna play it here. Same deal as the other one. Let's see here. Same deal as the other one. We also just take and use the alpha blend. So we use the output we make and the original output to make kind of you can see it looks kind of cartoonish. Maybe if I set down the threshold, we'll get more of just the lines. But here I like this threshold, and that's just what I used. I look kind of cartoonish with this filter on. I think that was fun to do, and just an idea that sprung to mind. Right. onwards, the Gaussian blur. And yeah, that's way too blur. And you can see my kernel here, kinda long. And we build it up by doubling it, kinda, not totally just doubling, but kinda. And then the total sum of all the pictures added together, we have to get down so it equals out to 1 to get the total picture, and then have a a single value that don't extend our max pixel value, and that way it will be blurred. And that's the same deal as the other kernel, where we take for each color and then a sum, and then use the kernel here. This time we go 3 bags because it is a big kernel, and again we multiply the kernel in and put the sum into the video feed, and yeah, at the end load it to the texture. And as you can see, it is very blurry, and I look very blurred. That's a big deal. Next filter, it's gonna be the max, and that is the median way of making a filter, just by taking the maximum instead of the middle value. And yeah, let's see here, there isn't really a kernel used, we're just gonna say we define our own kind of kernel. And also make it a black and white picture, because I like that. I make a unsigned char array, and we take just a 3 times 3 filter, and we load each of the output of the inside the kernel, or the fictional kernel that isn't visual anywhere, and we load it into our median array, which is going to be used for the max. Then we arrange the array here, and you can see we'll take and put the maximum value in the end, and then we display put that value into our output, and it's gonna look like this. And it will take all the light value, and as you can see, if I go close, my pupils will get smaller because my eye is wide, and then it will take those values because they are low and put them first. So yeah, my pupils will look smaller, and that's the way it works. You can look distorted and so on. Kind of a cool effect, I think. And you can see I got a really small mouth compared to the over on the other side, the normal picture. Right, onwards we go. Now we're just gonna do some blur filters, the mean filters instead of the Gaussian, which was the one with the really big and with large numbers filter. Right, here it's just we have to sum it up to 1, so we divide by 9, because 3 times 3 filter will add up to 9. And the same deal with summing it up, with multiplying with each kernel to a sum, and then put it into the output, and then of course the draw. I don't think it's necessary to show that, but yeah, you can see not as strong blur as the Gaussian. That's also because it's a smaller filter, but yeah, you can see it's kind of blurred. You can see it on my eyes, they're not that sharp anymore. So yeah, it works. Onwards to the next filter, which will be the mean 7 times 7 disk filter. Well, and the big point with the disk filter compared to the box filter is that the kernel will take values in a disk form instead of the box form. And you can see here we got one in the top and one in the bottom, and it will make kind of the disk form and only take those values inside the kernel. And we again got the same deal with the x and y for the kernels and adding them together and to the sum, and then put it in the output, and then print the output and so on, and also color. And it will be a stronger blur here because it's bigger, and it's, yeah, as you can see, a stronger blur than the mean, 3 times 3. And it also look a bit different than the Gaussian, not that much actually, I think, don't know, but not that much I think. But yeah, it also blur, so it works. Let's move on. Now it's gonna complain that it'll just be the median filter. It's again a range taking inside a kernel and taking all the numbers in there and put them into the array. Then I arrange it and take the middle value. In this case it will be a 9 point long array, and it will be value number 4 because we also have 0, so we have 0 to 4. It will be place number 5 inside the array, and that's the one we need, and we put it into the output and play the output, and yeah, we get the values and arrange the array, and yeah. See, it's also look kind of weird, but see, my eye isn't distorted this time, and I got kind of maybe a harder border up here because it will take the middle value of the values inside the array. Right, onwards to the minimum that will see the smallest value, so we'll get all the black values first, and it works like the maximum, just with the minimum. And to do that, we have just changed this symbol, so it will switch the other way, and then we again take position 0 and put it into the output. So as you can see here, it is only the dark. It's kind of shifted actually. I know it's just gone bigger, but as you can see here, my pupils, I think that's the best way to show that it works. It's taking, because we've got white in the eye, and you can see my pupils is a lot bigger actually, and it's almost no white back. My mouth also gets funny when I talk. Yeah, but that's that. Onwards to the next one, and now we get to the morph. Morphology, yeah. And no, we not a good idea to start with the close. We will start with the dilation instead. Right. The deal here is to first get an binary image, and then putting down a kernel over it, and then saying if it is white, we're gonna add to the sum, and yeah, and if it isn't white, we won't add to the sum. And then we say if the contents inside the pixel, this time it's a 3 times 3 kernel, if they exceed 1 white pixel, we will do that pixel white, else it will be black. So let's look at it, and we again use the skin color detection just for fun, and let's hope it will find me. And you can see on the other side here, all the pixel will be bigger. All the small pixel up here will become bigger, and yeah, my nose becomes bigger and everything. Yeah. Onwards to the erosion. This is dilation, and this is the erosion. Well, the idea for the erosion is that all the white pixels have to be white inside for this pixel to be white, so everything will get smaller. And it's the same deal with the sum, and find the white pixel and add it to the sum. And then we say if, because it's a 3 times 3 and the total picture inside this kernel would be 9, so we say if sum is equal to 9, we'll do that pixel white, else we'll make it black. So let's see what happens. It should work anyhow. Let's see if it can find me. It can, and you can see my head is smaller to this side, and all the noise up here will be kind of removed. Some place that will show up because there will be enough white pixels together, but else it will be white. Black. Sorry, noise will be black, of course. And my hand will be visible. And I will get some holes inside the hand, and that's because there is some noise, I will guess it is, on my hand. Well, let's get onwards to the morph close. And the idea here is to close all the gaps, so we first dilate and then erode, so we still have the same size of the shape, but we will close small holes in this shape. And oh, is it made wrong here? Well, this is actually an open, because we first erode and then dilate, so it would actually be an open here. So all the holes will get bigger. Let's see if we can demonstrate it. I think I'm doing something wrong here. It don't look like it dilated. Boom, boom, boom. Now it looks right. Well, maybe it's because I don't got that many holes in my face. Let's just look at it again. I would like to make the holes bigger. Yeah, but that's that. And if we want to make it the other way around, we would say this way and this way. Oh, like that. And then it will make the closing, because we first make it bigger and then smaller. Just a minute, then we're gonna play, and then we'll go onwards to the pre-width and sober. So now I just showed two filters here, waiting for it to start. And you see all the noises gone, and actually this looks, maybe I confused the two terms, but it's two different filters. Well, the pre-width, just gonna open here, and the pre-width was also the one I made the vertical lines with, and we get one, and we got the vertical lines here and the horizontal lines here. Then here we we go through both of the kernels, and then let's check if the sum is above this threshold, and we'll make it white or else black. So we should get both verticals and horizontal lines, and as you can see, we got also the horizontal line that the first filter didn't do. and we will get a lot of lines around me, and my hands will be, you see the lines on my hands and my eyebrows and so on. So it works. Boom, boom, boom. Then go onwards to the sobel. It works the same way as the pre-width, just with one number change. So we'll get more focused on the values to left or right, or above or below the value, the pixel we are checking. And you can see it here. We got 2 instead of 1 there, and 2 instead of 1 there. And then we go through the same way and take a threshold again. I made a bigger threshold, and for some reason I have not made it completely wide. We're just gonna do that right here and here and here. I think it's because I've just had fun and playing around with it. Right. The reason I have it outside the color, because we want to find the combined for the 3 colors and not for each color, find if there is a big difference. And we get the same, and some of this here is not showing, and that's probably because there isn't that sharp of line right there. But it works the same way as the pre-width, pretty much. The kernel just looked different. It's really fun to see my zipper. Yeah. And that is the end for the handling code 4 for the image processing course. And thank you for